Algebra 1, Section 4.5, compound inequalities. We got a definition for you there. A compound inequality is two inequalities joined by the word and or the word or. You got two kinds of compound inequalities. One of them is what I often refer to as the and situation, and the other one is what I refer to as the or situation. Please take a look at each. In this example, they're using the word and. Now, we'll talk about this in a second, but let's just think about what this would look like on a number line. We're talking about numbers that are greater than or equal to -5. So that's like this, with a closed circle on -5, and you would start shading this way. And x is less than 3, which means an open circle here at 3, and you'd start shading this way. And in fact, these are just going to come together. If I can get my starboard to cooperate here. They're going to come together to form an interval, okay? And the reason that this is the and situation is because only numbers that are along this segment right here actually satisfy both conditions. That's different than or. So for something to be or, it's either or, one or the other. It doesn't have to be both. For something to be and, it has to be both. It's like in National Honor Society, you have to have this grade point average and a certain amount of volunteer hours, right? If you don't have the volunteer hours, you don't get to be in National Honor Society. If you don't have the grade point, you don't get to be in National Honor Society. Well, again, to be on this line segment, I call it an interval, you have to be greater than or equal to -5 and also less than 3. -4 qualifies, -3 qualifies, -2, -1, 0, all the numbers in between. I'm just picking integers. 1, 2, 2.5, 2 3/4. Even -5, because that's the solid circle, because it's or equal to, would be included. But anything this way, not included, and it's not in our solution set. Why? Well, it is less than 3, but it's not greater than or equal to -5. So anything out here and throughout infinity to the negative, to the left of -5, not in our solution set. Anything to the right of 3, including 3, would not be part of the solution set. So with that in mind, it's really convenient to actually write it this way, okay? And I changed a word in my notes from prior where I said can be written. It really should be written this way. This is going to set you up for success more than trying to write it this way with the word and. I'm just telling you, experience talking here. Get used to this, just knowing that this is the and situation, and that's going to produce an interval on the number line. Okay. Now let's consider the or situation. X is less than 3. Here's 3. That's this way. X is greater than or equal to 6. Here's 6, and that would be this way. Notice that they're going away from each other, right? And this is the graph to this or situation, because thinking of 2, 1, 0, -1, -2, those are one or the other. All of those that I just listed are, in fact, less than 3. Okay, they're not greater than or equal to 6, but they are less than 3. Or the numbers here, 6, 6.5, 7, 8, 10, 50, 1,000,000, are all greater than or equal to 6. Therefore, it is one or the other, right? It's either this or this, not both. Both would suggest and. This is suggesting or. It has to be one or the other. Okay, two very different things. Or cannot be written this way. There is no or situation where you can put them together. Or must include the word or. And can include the word or, but I'm kind of discouraging you from doing that, but rather do this sort of more of an inequality sentence, if you will. All right, so let's take a look at some examples. Here you have rather odd looking example, actually, and I'm going to show you what they're going to do. This is the and situation. Now you say it looks different than the and situation that you just had on your starboard software, and that's true because on my starboard software these were less than symbols. But maybe you can look ahead a little bit and see the fact that you're going to divide or multiply by a negative number there, and that's going to turn those things around. Okay, so this will be the and situation here by the time we're done. Now look at their work. Before I show you the way I would have you to do this, look at what they do. So they basically ignore this right here for the moment, and they take the rest of this and they solve the inequality like you would have earlier in the year. Takes a few lines, right? And they did divide by -1, so they did have to switch a sign. Yeah, they switched it right there. Okay, that was okay. Yep, and so then they get f, essentially f is greater than 0, okay? And then they ignore this part of it and they solve this inequality with the and situation. And here you'd subtract 5 from both sides. And then you'd have to divide by -1 again. Okay, and they're showing more work than you need to show, but even still, I mean, isn't this a lot of work to come up with that? Okay, I'm going to suggest you just avoid all of that, and rather do it this way. Take 5 is greater than 5 minus f greater than 2. And you're already accustomed to doing whatever you do to the left, you have to do to the right for equations, chapter 3, and now inequalities, chapter 4. And we're still on the lookout for that big exception when you divide or multiply by a negative number. Now you're just going to do that same thing, but you're going to do it in 3 places. Ask yourself what's happening to the variable and then undo things in reverse order. Well, the variable is being added to 5 and then basically made negative. Okay, it's hard to think of it in terms of subtracting from 5 when we're trying to get it by itself, but basically it's being made negative. I'm sorry, I said it in the wrong order a minute ago too, didn't I? It's being made negative and then it's being added to 5. So we want to subtract 5 from both sides. This would be 0 greater than negative f greater than -3. And then we want to get f by itself. It's negative right now. That's like, it's like saying that it's being multiplied by -1. So we could divide by -1, divide by -1. When you divide an inequality by -1, you have to switch the sign, even if it's like this, where you're going to be switching 2 signs. So 0 divided by -1 is 0. Negative f divided by -1 is f. -3 divided by -1 is 3. And less than becomes, greater than becomes less than. This is the and situation. Okay, and again, that other way that I showed you, it works. I don't mind it, but it's inefficient, and it's really not going to help you. It's going to be even more hurtful than helpful, I think, when we do section 4.6. 4.6 builds off of what we're learning right now. By the way, on a number line, if here's 0, 1, 2, 3, 4, 5, 6, we're talking this interval, right? 0 to 3. Next example. Skipping that one. This says write an inequality that represents each situation and then graph the solutions. All real numbers that are less than 0 or greater than 3. Number line, 0, 1, 2, 3, 4, 5, 6. This is similar to the one we just did, except this is an or situation. They're going to be moving away from each other, not towards. And less than 0 or greater than 3 would be like this. Discounted tickets are available to children under 7 years old or to adults 65 and older. Now that's a little bit more challenging to get a consistent scale, and I don't think the scale is really the point here. So let me just kind of estimate. 0, 7 would be like here, and then 65 might be way out here like this. Okay. Now the scale may not be perfect. I'm 100% certain the scale is not perfect, but to do so, yeah, you might want to go by 5s or whatever. I'm trying to keep this video short, so you'll get what I mean, and it's not even an issue anyway when it comes to problems like this. And we've seen plenty of problems with that anyway, talking about scale. Anyway, discounted tickets are available to children under 7 years old or to adults 65 and older. Does that sound like it includes 65-year-olds? It does. Children under 7, does that sound like it includes 7-year-olds? No. So I'd say that, right? So 65 and older is the inequality or equal to, 65 and up. Children under 7 means 6-year-olds and below. Okay, so we got an open circle at 7. And you might just draw an arrow here and not really think about it, but technically children are never below 0 years old. So really, this is what we're talking about. Okay. Now, I graphed them first, and you can do it in either order. I thought that maybe the visual would help us to write the inequality. So the inequality here would be x is less than 0, must use the word or, x is greater than 3. Whereas the inequality here, very interesting, I think, would be the interval. And I don't mean to be confusing here, and I wish maybe there was another example we could have done kind of intermediate to this. So again, don't be too hung up on the fact that I'm going to combine two things. But basically, we have a segment, an interval here, and then we have an or this as well. So really what we have is 0 less than or equal to, I guess I'll use x. X, you could use a for age or something like that. Less than 7, or x is greater than or equal to 65. Now I wonder if they've included the 0, really, because I think the emphasis is on the or part. So this much. Let's roll to their answer and see what they have. Oh, they do. They did include it. Huh. Okay. Yeah. So we pretty much covered it the way they did. All right, one more. Solve the compound inequality 3x plus 2 is less than -7, or negative 4x plus 5 is less than 1. Now, we've solved these kind of things individually already, so I don't feel the need to talk through it. Let me just kind of roll to it. Notice that they kind of want to keep that or in the middle. You must include or in your answer. Here you would subtract 2 from both sides and divide by 3. And you get x is less than -3. Here you would subtract 5 from both sides and then divide by -4. Ding. Divide by -4. And less than becomes greater than. This is your answer right here. And then we can graph that. It's an or situation. That means that the arrows are going to be going away from each other. Your number line should look like theirs. Okay, that's all.